Students, this is a fantastic problem that asks us to tie together our knowledge of gases with our knowledge of empirical and molecular formulas. They give us a little bit of information about a gas that's held in a flask. They give us a volume, a temperature, and a pressure, and they give us its mass. We're going to definitely use the ideal gas law to get the number of moles, and then we'll use the number of grams along with the number of moles to get the molar mass. And then we'll look at the formula, the empirical formula which they gave us, and compare the molar mass to the empirical formula mass in order to find the multiplier that we need. Let's start by converting some of the units that they gave us into units that we can plug into the ideal gas law. So for instance, 256 milliliters, if we convert that into liters before plugging into the ideal gas law, that helps. 750 torr, if we divide that by 760, we get 0.986, or 0.987 rather, atmospheres. And we'll use the ideal gas law, PV equals nRT. In order to use the gas law constant 0.08206, we have to have units of atmospheres in liters and temperature in Kelvin. So that's why we made those conversions. Okay, 0.987 atmospheres times 0.256 liters equals some number of moles, which we will find, times 0.082206, and the units for R is kind of goofy ones. Liters, atmospheres over moles times degree Kelvin, and the temperature they had given us in the problem is 373. If we solve for number of moles, in this case we get 0.00825. That information, along with the mass that they gave us in the problem of 0.8, will enable us to find the molar mass of that compound. Molar mass is simply the number of grams per moles. Well, now, for a given size sample, we have both of those. We have the number of moles, and we have the number of grams. So we'll divide the number of grams, 0.8, by the number of moles, 0.00825. And in this case we get 96.9 grams per mole. Now, we've got the molar mass, and we were given an empirical formula. Well, we can use the empirical formula to get the empirical formula mass. In CHCl, we have one atom of each type. One atom of carbon, one atom of hydrogen, and one atom of chlorine. And if we add all of that up, we get an empirical formula mass of 48.5 grams per mole. Now, an empirical formula is just the simplified or reduced version of the formula compared to molar mass. So now, to figure out how to go from empirical formula to molecular formula, we need to look at that ratio of molar mass over empirical formula mass. And so we just divide these numbers, and we're looking for the closest whole number ratio. These are going to be really close to 2. So 2 is what I call the multiplier for the subscripts within the empirical formula. So if the empirical formula is CHCl, then to get the molecular formula, we would take all of those and multiply by 2. So C2H2Cl2. And it doesn't matter the order that you list them in, as long as you have a 2 behind each one.